why we want to use this technology, indexing technology, inside DBMS. So this technology is built in DBMS. Yeah. The purpose is very simple. For fast retrieval of the data. Yeah. So if we apply this technique or technology, yeah, so whatever you can call, yeah, then we have a chance to find our data in the fastest possible way. Yeah. All right, so let me explain the idea. Yeah. And in this class, we do not plan to go very deep. Yeah. So basically, I describe the general high-level idea. Yeah. So we won't dig into very deep for a lot of details. Yeah. Not necessary. Yeah. All right. First, the goal, speed up the retrieval of records in response to certain search conditions. Yeah. And usually, when your table is very large, then we apply this technology. Yeah. If the table is, not very large, yeah, so that, for example, even dozens of or even hundreds of in that level, no, we do not need. Yeah. But if your table, the size, the number of rows, too large, yeah, thousands of rows or even millions of rows, yeah, yeah, millions of you, definitely you want to apply this technology. Okay, or even billions of, yeah, huge. Yeah, so you must use this technology. Yeah. All right. Then the idea. Yeah. The structure of the data is important for the performance of data retrieval. So we need to explore the structure. We want to take advantage of some special structure of our data. Yeah. But our original data, we know the data is collected from our business operations. Yeah. So for us, we are technical people. For us, we cannot control the data collection, that step. Yeah. So we just take the data from the business people, whatever it is. Yeah. Then, after we get the data, then we try to put some special structure on it. Yeah. But we don't want to change the original data, the state of the original data. We don't want to change because we want to keep the original business data. The business people, they don't want to see the change, right? Yeah. If we change, those business people, they could be very mad, right? Yeah. So we don't want to do that. So we want to preserve the original data form. No change. But we will do some special arrangement that we can control, but the business people, they do not need to know this. Yeah. We technical people, we have a lot of room, so we can do the manipulation, and we do not need to tell the business people, because we do not change the original data. They only need to access the original data. Okay? Yeah. But behind the scene, we have a lot of room. We can arrange some special way for the business data. Yeah, that idea. Yeah. Let me elaborate this idea. All right. Yeah, should not be changed. Yeah, so to make our business people happy, So we should not make any change on the original data. Okay? But if you do not, how can you add your special structure on it, right? Yeah. There is a way. Yeah. There is a way. The way is very simple. Yeah. We will add auxiliary data. We will create auxiliary supporting data associated with the business data. That idea. Yeah. Then, because the auxiliary supporting data is created by us, okay, technical people. Yeah. Then we can control it. Yeah. We can manipulate that auxiliary data, yeah, but not original business data. That idea. Okay? Yeah. All right. Yeah. Yeah. So what's the, yeah, so, yeah, all right. Right. But, yeah, if we look at the original business data, because the data usually collected in a random way, right? Yeah. Random way. Yeah. Most of the time, yeah. That means there is no order when you collect the data, right? Yeah. And here, yeah, if you work on the original data directly, then it may not support good performance. Yeah, what do you mean good performance? Because here I need to, give you more information. Yeah, because no order information in general, right? Yeah. Not ordered in general. No order info. Yeah. No, it's not well organized. Okay? Yeah. All right? Yeah. So you cannot take advantage of the order information to speed up your retrieval operations. Yeah. That's all. Most of the time, in general. Yeah. In a very small, rare, special case, your data could be ordered based on some particular field. Yeah. Yeah. In that case, then you can use that ordered structure. Yeah. All right. But if no ordered structure on the original data, then we can order our business data, but on the auxiliary, right? On the auxiliary supporting data. Yeah. Then we can sort it. Yeah. For the original business data, you cannot sort. Yeah. If you sort, so you change the order. Yeah. The business people, they do not like to see any change on the original business data. Yeah. All right. Yeah. So create auxiliary access structures, indices. Yeah. That's the, high level idea. Yeah. The motivation. Yeah. Why we use this technology. Yeah. All right. Next, we need to understand the structure of this indices. Yeah. Indices. Yeah. All right. Yeah. All right. Based on indexing fields. Yeah. All right. So here, let me draw a typical table. Yeah. Suppose this is one table. Okay. In this table, we have many fields, right? Yeah. Fields. Yeah. And when you do the search, many times we base on the field value, right? Yeah. Here, let me use F1, F2, and so on. Okay. FK. Yeah. When you do the search, given some, search key value, VK, for example, Fk equals Vk. How do you find the row matching this search key? Yeah, okay. Yeah. And when the table size is very large, okay, yeah, think about that. Yeah. All right. Yeah. So you can see based on indexing fields. All right. So if you need to have operations like this, then you need to make this field as the indexing field. You need to create one index file for it. One index file for it. You need to create it. Yeah. Create one index file for it for faster search. Yeah. So if you do the search operation with this condition, then you can take advantage of the special structure in your index file. All right? Yeah. So based on, but sometimes you may need to do the search based on a different field, right? Yeah. So then you can make this field another index file. Yeah. So that means for one table, you can create multiple index files. Yeah. Yeah. Based on your needs, in your business. Yeah. So if you need to do the data search based on certain fields, yeah, so then it's better for faster performance. So then you need to create index files for those corresponding fields. Yeah. All right. Yeah. Yeah. So multiple index file. Yeah. All right. Then index basics. Now I need to describe the specific structure, yeah, for the index files. Yeah. And how can we make the data search very fast? Yeah. All right. Secondary access path. Primary, we access our original data directly. That's the primary access. Yeah. Then this is secondary access paths. Yeah. All right? So auxiliary, supporting, and secondary. Yeah. So it's a different path, different access path. Yeah. All right? In our primary access, we access our original table directly. Given a key, how do you find the row with the given key value? You need to do sequential search, right? One by one. One by one. Then that's very slow. Yeah. If your table size is very large, so that usually very slow. Yeah. All right. Now, when we do the search on the secondary access paths, yeah. So we want to make our search much faster. Then you use the primary access paths. Yeah. All right. How? Yeah. Additional files on disk. Yeah. Index files are additional files on disk. Yeah. Hard disk here. Yeah. Because our data. Yeah. So here, imagine our data is stored on hard disk. Yeah. Not in main memory. Okay. In memory, you can only load a portion of your data. But the whole database is stored on your hard drive. Yeah, because your whole database, the size is very large. Yeah, you cannot, usually it's very hard to load the whole big database into your main memory directly. Yeah, here we're talking about large databases. Not small databases. Yeah. So for our classes, Usually we use very small databases. Yeah, that can be loaded into main memory easily. Yeah. But for very large, think about several gigabytes, many gigabytes, that size databases. Then it's hard to load all of them into the main memory. Yeah. But we don't need. We just load portion of. When we need to use this part of data, then we load. Otherwise, we do not need to load. Yeah. All right. Yeah. Using extra storage space in exchange for better performance. Yeah. So here, yeah. How can you add a special structure on your additional files? Yeah. Yeah. So now we can, because we can organize our auxiliary files, yeah, data in our auxiliary files. We have freedom to do it. Yeah. Yeah. Because we do not need to touch the original business data. Yeah. But for auxiliary, yeah, we create it. We create the auxiliary additional data files. So we have freedom, a lot of freedom to manipulate these files. Yeah. All right. How? Yeah. So here, how to do it? Sorting. Yeah. So here you can see the main idea is we can sort. We can sort our index data stored in the index files. Yeah. We do sorting, right? Yeah, yeah. We do not sort the original table, yeah, but we can sort the index files. Yeah, we can do sorting. Yeah. After you do the sorting, your data is ordered in those index files. Yeah.
So it's like an Excel spreadsheet almost the way this.
Yeah. Right. Right. Yeah. Yeah, but it's a hidden, additional, extra. The business people, they do not know this. Okay, so we add some supporting structure. Yeah, so the business people, they never know it. Okay, yeah, we do not touch their original data, but in a hidden way, we make the data search much faster. Many times faster. Okay? Yeah. All right. Yeah. So here you see that, the main reason we can make it very fast is we make unordered data to ordered data. Yeah. Because the original business data, usually it's unordered data. Okay? Now, yeah, so we make ordered data. Yeah, but not on original, on the supporting files. Okay, yeah, not on original files. Yeah, original files always unordered. Okay, original files always unordered. Okay, yeah. Yeah. Then, for the ordered data, you can see immediately we can apply the binary search. That's the reason we can speed up in greatly. Yeah. So the difference is the linear search versus binary search. In the original file, if you want to do the search, if it's unordered, you can only apply linear search, right? Yeah. Linear search. Linear search, we know if we use asymptotic notation, that's big O of n. Okay? Linear search. Yeah. Then, if we apply the binary search on the ordered data, supporting data, right? Yeah. So the asymptotic notation is log base 2 of n. That's a huge difference. That's a huge difference. Okay? Yeah. All right. Yeah. Yeah. Here, I can show you some simple examples to show you the huge difference. Yeah. Let me give you some simple examples here. Yeah. The example for comparison purpose, all right? So when n, number of rows, equals, let's say, 2 to the 20. 2 to the 20, okay? Power of 2. So that's in the million size, right? Approximately 1 million, okay? 1 million, all right? But if you do the linear search, right? Yeah, linear search, this big O of n, so that's million, right? Yeah, the average 500,000, right? Because we consider the average case 500,000. Okay, yeah. So if we use big O of n search algorithm, 500,000. Yeah, 500,000. Or let me write it as a number. 1/2. 500,000. Okay. Comparisons. All right. Then now we use the binary search. Okay? Yeah. Then we take the exponent number, right? Because we take log base 2. So 20 comparisons. Look at the huge difference. Okay? So you reduce the number of comparisons from 500,000 to 20. How big is that? Okay? Yeah. 500,000. Yeah. On average, you need to do 500,000 comparisons to find the location of your data on average. But this binary search way, 20 comparisons. How big is the difference? Okay? That's huge difference. Okay? So that's why, when you need to do fast search on large database basis, you need to consider this technique. Yeah. All right. Yeah. Yeah. So here I just use the million. Yeah. You can imagine if we use billion, so then even huge, right? Yeah. Billion. All right. So 500 million versus 30 comparison, right? Yeah. Because the billion level, binary search, you need 30 comparisons, 10 more. But linear search, 500 million. Yeah. That's too slow. Yeah. Extremely slow. Yeah. All right. Yeah. Does not affect physical placement of records in the primary data file on disk. Yeah. So, yeah. All right. So I can erase it. Yeah. All right. So. All right. Yeah. Yeah. So then there is no change in the original data. Yeah. So the business people, they cannot complain. Okay? Yeah. So we preserve the original business data. Yeah, they cannot complain. Yeah. All right. Now, indexing fields. Now, let's look at the details of the index file. Indexing fields. Yeah. We need to, because when you do the binary search, you need to sort your data based on one particular field, only one of the fields. Yeah. So that's the indexing field. Yeah. All right. Basically, any field of the file can be used to create index. Yeah. So you look at which field you want to use to make the search. Yeah. So that field, you want to create an index file. And that field, you use it as the index field. Yeah. Indexing field. Yeah. All right. Yeah. Not necessarily those fields with total ordering. Yeah. So here, there is one special question I want to mention here. Total ordering. Yeah. So I talked about the concept before. Yeah. Yeah, total order. Yeah, total order. Yeah. So what's that total order? Yeah. Yeah. Total order. Any two values in the domain you can compare. You can use greater than, less than, equal to compare. Okay? You can order. Yeah. You can get a larger value, smaller value as a result of your comparison. Yeah, total order. Any two. Yeah. Yeah. Partial order, you may not have this property. Partial order, sometimes you can get order information, sometimes you cannot. That's the partial order. All right. Yeah, but here, not necessary. Yeah. So here, yeah. Because if we use the binary search, we have to rely on order information on the indexing fields. If you cannot sort your data based on the indexing field, then you cannot apply binary search. Yeah, so that's no problem. Yeah, but binary search, yeah, this method is the main method for indexing technique. So binary search is the main method. Okay. This binary search, main, no, sorry, right here, main method. Yeah, all right. But it's not the only method, all right? It's not the only method, right? Yeah, yeah. Because if there is no total order property for the indexing field, that could happen. But the percentage is very small, but that could happen. Then we cannot use binary search. There is another way. We can create our index, hashing. Yeah. So that's why we say this is not necessary. Why not necessary? There is a small percentage case we can create indexing files based on the hashing technique. Yeah. Hashing technique. Yeah. Hashing, yeah. The search operation also very fast. Okay? So hashing technique, we know the average search bigger of 1. Also very fast. Yeah. Yeah. But the problem, yeah. So here the hashing technique, the search operation bigger of 1, better than bigger of log base n, right? Log base 2 of n slower than 1, right? Yeah. But the problem is, yeah. So our first priority still the binary search. Hashing weight is the second priority, not first. Okay. Yeah. The reason is the binary search, we have that very important order information. Yeah. Many times we need this order information. Okay. Hashing, no order information. Okay. So you can find it, yeah, but not based on order, based on your hash functions, yeah. Yeah, hash function values, that way. Yeah. But there is no order in your index file. Yeah. No order. Yeah. Yeah. Yeah, because many times the order information is very important. Yeah. So our first priority, we want to have the order information. Yeah. Yeah. If we have no chance to get all the information, then we can only use this hashing way. Yeah. All right. Yeah, let me, yeah. All right. So, so that's why, yeah, this has, do not use sorting, yeah. Because the domain does not support sorting. The domain doesn't. Yeah, that percentage extremely small. Yeah. Yeah, but not zero. There is a very small percent. Yeah. All right. Data structures for indexing. Now we need to learn more details about the specific structure of indexing files. All right. Ordered files. Yeah. Yeah. Require. Yeah. So use binary search. Yeah. So we already talked about. Yeah. Right. Yeah. So the it's a most popular way. Yeah. Yeah, based on binary search. Yeah. All right. Then another important improvement is this tree data structure. Yeah. So here, let me spend some time to explain the improvement part. Yeah. This tree structure is for the improvement part. Yeah. Before we use tree structures, before we use tree structures, yeah, all right, yeah, we have line structure, right? Yeah, because when you do the sorting, your data is ordered on a line, okay? Yeah, yeah, all right? It's not a tree, okay? So then you apply binary search on it. Okay, all right. Then people still not very satisfied with this line structure way to organize the data. Feel not fast enough. Yeah, why? Yeah. Let me explain why still this structure, line structure way, still not fast enough. Okay? All right. Yeah. Why? Yeah, let me explain. Yeah. Because here, let's consider the cases n equals to 1 million, 1 billion, right? Yeah. For the 1 million case, yeah, so this linear way you need 20 hard drive accesses, right? 20 hard drive access. This case, you need 30 hard drive accesses. All right, yeah. Here you can see 20, 30, it's a not large number, but we know hard drive access is pretty slow, right? Comparing with the main memory accesses. Data in main memory access, yeah, much, much slower, okay? So here, we need to compare it. Oh, yeah, I need to, right here. We need to compare it with main memory accesses. Yeah. Because when we load the data into the main memory, yeah, we access data from main memory much, much faster than hard drive accesses. Yeah. In what level? Yeah, the level close to 1 to 100 in that level. Okay? Yeah. So that difference, yeah, not exact, but approximate level, 1 to 100. Yeah. Approximately in that level. Okay? Yeah. Main memory accesses, that's 1 unit of time. All right? Yeah. 1 unit of time. But the same data piece, if it's on a hard drive, you need 100 units of time. 100 times slower. Okay? Yeah. So that's why it's too slow. Yeah. Too slow. All right. That means even this 20, 30 hard drive accesses, we still feel too much. Yeah. We want to reduce that number. Okay? Yeah. We want to greatly reduce these numbers. Okay? That's why, yeah, this tree structure is used to greatly reduce hard drive access numbers. So change from the line structure to tree structure. Okay? Yeah. All right. So let me, draw the idea a little bit, the tree structure. Line structure, yeah, all right. So we start from the root, okay, all right. Then, there are many branches, yeah, all right. Then you have a node, then many branches, okay. So not a binary, okay. Usually the number of branches, it's a, relatively large number. Okay, yeah, dozens or hundreds, yeah. So usually, sometimes based on the data size, yeah, how many bytes in your data field you used, yeah, based on that, yeah. So more than 100 or less than 100 in that level, okay? Around 100, yeah. Above, below 100. So that number of branches, like that, okay? So the tree structure, yeah. This tree structure, then, yeah, you can organize your data level by level, okay? You build a special tree in this one. The nice thing about it is, yeah, if you use the multi-level, so tree structure we call the multi-level. Yeah. The line structure we call the single level. Yeah. Only one level. Yeah. This way you have multi-level indices. Yeah. So the multi-level indices more complex than the single level, but you can reduce the hard drive access numbers greatly. Big improvement. How big? Yeah. Here I give you some idea. How big is the improvement? Okay, for the millions or billions of data search, when you use the multi-level tree structure, you can reduce the number to 4 or 5. 4 or 5, okay? Yeah, that's enough, okay? Yeah, 5 for billions, already enough. 5 levels, okay? You only need to do 5 comparisons, 5 hard drive accesses. So you can find the location of your data among billions of rows, okay? Yeah, so that's extremely efficient way using the multi-level indices. Okay? Yeah. Yeah. All right. The details, yeah, for this class, I do not talk too much about details, but I will give you some partial information later. Yeah. Yeah. Some partial. So to help you understand why we can improve our search operations so much. Okay? Yeah. From billions of comparisons to 4 or 5 comparisons. Right? So that's the huge improvement. Yeah. 5 comparison, that's the maximum. Yeah. So because billions of rows, that should be good enough, right? For typical real world applications. Yeah. All right. Yeah. Yeah. Dynamic structure. Yeah. So another important thing we need to consider. So here I want to talk about this tree data structure. Very complicated. Yeah. Very complicated. Yeah. The manipulation, the algorithm to manage this multi-level indices, very complicated. Yeah, but there are some efficient algorithms to support this tree data structure. Yeah. So the name, B tree and B plus tree. Okay. Yeah. So the name of the structure. Yeah. B tree. So that's the first B tree. But another improvement, okay, B plus tree, better than B tree, yeah, yeah. But based on the B tree, yeah. So then B plus tree, yeah. So then we can manage the complex structure of our data in multi-level. Yeah. All right. Yeah. Dynamic structure. Yeah. It means because when we work on our business data, we need to keep updating, right? Yeah. So insertion, you need to insert new data, and then you need to delete some data, So you need to maintain the structure in a dynamic way. Yeah. Yeah. So that means this tree structure must support insertion and deletion. Now, when you insert a new node, what's the algorithm to do the insertion? Okay. And maintain this well-organized multi-level tree structure. Yeah. When you delete a node in this tree, so how do you maintain the structure? Yeah. Yeah. It's very complicated. Yeah. But if I have a chance, I will say something. Yeah. Give you some main properties of B tree, B plus tree. Yeah. Data structure. Yeah. All right. Then hashing. Yeah. So another. Yeah. It's fast, but no order information. The main drawback is no order information. Yeah. Yeah. Because the order information is very desirable. Yeah. So if we have any chance to have order information of the data, we should do it. Yeah. So that's why our sorting way, binary search sorting way, that's our first priority. Yeah. So because we can have this order information. Yeah. And the B tree, B plus tree rely on the order information to build. Okay, that's another reason. Yeah. Yeah. But the hashing, yeah. Hashing because we do not have the order information. Yeah. So we cannot build B tree, B plus tree. But for hashing, we don't need a B tree, B plus tree, right? Yeah, hashing because its search performance already bigger of 1, right? Already bigger of 1, so we don't need to build multi-level. Yeah. So that's different. Yeah. All right. Yeah. All right. Yeah. So yeah, I'm pretty much how indexing works. To find a record in a table, let me describe. Find a search condition based on a field. Yeah, that's our search condition. Assume that an index is created on the field. Yeah, index created. And the data in our index file, we sort the data based on the indexing field. Okay? Yeah, we sort it. Yeah. Not on original table, but on this indexing file. Yeah. So we can sort it. All right. Yeah. So then, when we do the search, we search the index file. Okay? So here you can see when we make our search. Yeah. Yeah. All right? When we make our search, we work on the index file directly. Okay? Yeah. We do not search the original file. Yeah. We do the, because we need to determine the location of the data on your hard disk. On your hard disk, where is the data stored on the hard disk? We use the index file to tell us the location of the storage location of your target data on the hard drive, hard disk. Yeah. All right. Search result of the index, binary search. So you apply the binary search. Yeah. So you can find the, so here I need to use the specific structure of the, one indexing file, okay? One indexing file. Yeah, all right. One indexing file, the structure, there are two columns, okay? Only two columns, all right? The first, so key, and also the, that's the indexing field. We use the indexing field as the key column, okay? Indexing field, key column. Then the second column is the pointers. Pointers point to the location of your, of your business data on hard disk. Hard disk, green, hard disk. All right, yeah, okay. So a pointer to the disk block, yeah. So here, yeah. Because later when we need to understand more detail, we need to understand the basic structure of hard disk. Yeah. Today we don't have enough time. Yeah. Next class, because in order to understand how do you get the locations on hard disk, you need to know the specific structure of hard disk, the way to store data on hard disk a little bit. Yeah. So probably review. I believe you learned it before, but here we just recall. Yeah. Your memory. Yeah. Yeah. So a pointer to disk block that contains original requested record. Okay? Yeah, pointers. All right. The primary index. Yeah. The structure, yeah. An ordered file whose records are of fixed length with two fields, key and the pointer. Yeah, so that one. Yeah. So this part, yeah, this sentence, this line, this property, it's a common for all indexes. All indexes, we use this structure. Okay? Yeah. So therefore, the primary index, then we have some special requirements for the primary index. All right. Primary key of a primary index. Yeah. This key part, yeah. This key part for the primary index, we call the primary key. Yeah. Here, you may have a confusion. Yeah. Because we use the primary key, this term, in our SQL table before, right? These two concepts are different. Okay? The primary key of primary index is different from the primary key of our regular SQL tables. Different concepts. Yeah. So it's very easy to get confused. Yeah. Yeah. All right? So here I pointed this out. Later I will explain how different these two concepts. Yeah. All right. So the primary key of primary index. The first field is of the same data type as the ordering key field of the data. Yeah. Yeah, because when we start from original table, yeah, this is original table. Okay? Yeah. Suppose this is indexing field. Okay? We want to use this field as the indexing field. All right? Then we need to define a primary index. Now we need to create a primary index. Okay? All right. So the primary index, two columns. Okay? Yeah. The key column, the first one is the key column, second is the pointer column. Key column and the pointer column. Okay? The key column, we use this indexing field. Okay? Yeah. But this indexing field, yeah, the data should be ordered. Yeah. So ordering key field. So that's why, yeah, in order to apply primary index, this data, there is a requirement. This data, the data in this column must be ordered. Okay? If it is not ordered, we cannot apply primary index, but we can apply secondary index. Okay? Yeah. Yeah. Primary index and secondary index. Okay? If it's not ordered, yeah, most of the cases are not ordered. But we can order it, we can sort it, but in that way, if we sort it, then the index file we will use, we call the secondary index, not the primary. Primary, we do not need to sort it. The original business data based on this field already sorted. Okay? Yeah. Then we can save more. Yeah. Because if it's already all ordered, then when we create an index file, we do not need to use index entries for all the rows. We can jump, okay? Yeah, we can take advantage of that order information. We can jump. The secondary, you cannot jump because it's not ordered. When you order it, then the number of index entries equal the number of rows in the original table. Primary index, the number of entries is much smaller than the number of rows in the original table. That's the main difference. That's the main difference. All right. All right. That, excuse me. The second field is a pointer to the disk block that contains the record to be searched for. Okay, yeah. Yeah, last few minutes. Number of, yeah, I just talked about number of index entries, right? Yeah, let me drink some water. Yeah, so then these two types of indices, primary and a secondary. All right. We need to look at the difference. There is one index entry in the primary index file for each block. Let me erase a little bit. Where is my pen? Yeah. Bottom. All right. Let me erase a little bit. Yeah. All right. So one index entry in the primary index file for each block in the data file. Yeah. To understand this sentence, today we cannot understand. Today I just give you this property to explain why one entry for one this block. I need to draw the hard disk structure first. Okay? Then, after you understand the structure of a typical hard drive, then the blocks, then I can explain why it's a one-to-one correspondence. One index entry, you only point to one disk block. One disk block may contain multiple entries. One disk block. Next time I will explain the block concept. One disk block, you can store many index entries in it. Yeah. All right. Yeah. So there, anchor record in primary key. Yeah. So here, this new slide, I think I should not go to this new slide. Yeah, because too much to digest. Yeah. Let's just stay in this slide to complete. Yeah. But I need to prepare for the next class. Next class, in order to understand the primary index. Yeah. So I need to draw the diagrams, showing you the primary index structure and at the same time the hard disk structure. How to store data based on the disk blocks, consecutive disk blocks on the hard drive. Yeah. So after you understand that, then create a one-to-one correspondence. Okay? So you know how to. So the purpose is we want to use the minimum number of index entries to store the locations of all the rows in the original table. Yeah. All right. So that's the goal. Yeah. Minimum number of entries. Yeah. Because the smaller the entry numbers, then the smaller the binary search comparisons, right? Yeah. All right. Let me stop. Yeah. The smaller the number of comparisons in your binary search. Yeah. Okay? Yeah. All right. Yeah. So let me stop right here. Yeah. So next time we continue. So first we complete the primary index. Second, then we study the secondary index. Yeah. So then we pretty much finish this topic. But I need to talk about how, the structure of the hard disk first. Yeah. So I try to control using 3 classes to complete this topic. Then the last class we do review for the final. Yeah. All right. Yeah.